Okay, yeah. So number 18 is kind of like a classic like pattern noticing question. So it says the diagram represents a 7 foot by 7 foot floor that is tiled with 1 square foot black tiles and white tiles. And we say the question tells us that notice that the corners have white tiles, and we want to know if a 15 foot by 15 foot floor is to be tiled in the same manner, how many white tiles will be needed? Um, yeah, so for this question, like these kinds of questions, it's a very common kind of question where they give you a small case and they want you to generalize it to higher numbers. So they gave us the case for a 7 foot by 7 foot floor, and we want to know how many white squares will there be in a 15 foot by 15 foot floor. So sometimes in these questions, you kind of need to notice a pattern. If you can't see the pattern right away, it's usually a good idea to start with small examples. So in this case, we're given 7 foot by 7 foot. So let's first take a look at how about, maybe a 7 foot by 7 foot is too complicated. How about let's take a look at a 1 foot by 1 foot floor. Well, that's not very interesting. It would just look something like this with one white square. So that's not very interesting. So let's take a look at like a 3 by 3 floor. And the reason I skipped 2 by 2 is because like in this case, we're always focused on like odd numbers. So like here they have like a 7 by 7, and you want to find a 15 by 15. So that's why we're just going to ignore even numbers for now. So if we were to draw a 3 by 3 rectangle or 3 by 3 floor in the same pattern, we would have like, if we follow the same pattern, we would have like these squares are black and the 4 corner squares are white. So in this case, we would have 4 white squares. In the first case, we had 1 white square. So let's take a look at like a 5 by 5 square. If we color the 5 by 5 square in the same manner, these would be colored, these would be colored, these would be colored, and these would be colored. So notice we have like 9 white squares in this case, right? The 9 white squares are here, 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 and here. And maybe you notice a pattern, right? If you look at the 7 by 7, if we were to just count the white squares, we get 16 white squares. So 7 by 7 floor, you would have 16 white squares. So probably the obvious pattern is you start to notice like the perfect squares, right? You see you have 1, 4, 9, 16. Like, 1 is equal to 1 squared, 4 is equal to 2 squared, 9 is equal to 3 squared, 16 is equal to 4 squared. So we can just kind of continue this pattern, right? We know an 11 by 11 would have 5 squared white tiles. A 13 by 13 would have 6 squared white tiles, and a 15 by 15 would have 7 squared white tiles if we just like continue this pattern. So if let's oh, actually that's not true because I skipped like 9 here. So actually after 7 by 7 you have 9 by 9. A 9 by 9 floor would have 5 squared white tiles. Then after 9 you have 11 by 11, that would have 6 squared white tiles. 13 by 13 would have 7 squared white tiles, and finally a 15 by 15 floor would have 8 squared white tiles if you just continue the pattern. So the final answer would just be 8 squared, and you would get an answer of 64. And then you look back at your answer choices, and that would be choice C. And yeah, that'd be the answer. I think the most important part about this question was just like identifying the pattern. Just like if you can't see the pattern right away, usually it's a good idea to try small cases and look at the small values. Usually that will help you, find a pattern. And this is actually a very like powerful problem solving strategy, especially when you get to like definitely more complex problems. Even like hard problems, like you can, if you were to look at small cases and you try to notice a pattern and you generalize that pattern to larger cases, that's actually like a very common problem solving strategy. And so it's a very like important to like be able to identify patterns from small numbers and being able to generalize that pattern to like larger numbers. And yeah.